We're interested in finding the remainder when this number is divided by 1,000. Now, the thing is, this number is very, very big, so we don't actually want to work out the whole thing. And here's the thing, when we have a big number like 731,582, if I was to divide it by 1,000, then it's actually, I could write it as 731,000 plus 582. I'm not going to get a remainder from any of these digits or ones that are even larger. The remainder is going to come from the last three digits. So the remainder here when I divide by 1,000 would be 582. And that is going to be the same for this number. So I only need to look at the last three digits. Right, the last three digits of 202, 202. For 20 to the 21, this is actually going to be multiples of 10, lots and lots of times. And so it's going to end in three zeros. Don't need to do anything else with that. It's actually going to have absolutely no impact whatsoever on the remainder when we're dividing by 1,000. And now we just need to focus on 2 to the 21. There's a quick way of doing this, and there's a much slower brute force kind of way. And I'm going to start the brute force method off, in fact, and I'll show you the quick way. So the brute force method is just to keep timesing by 2 until we've done it 21 times. Having said that, we only need to focus on the last three digits. So once you go beyond the last three digits, you can ignore those digits. So that's 2 to the 5. It's quite quick to do. And this is 2 to the 10. Now, in fact, I'm going to pause my brute force method and use that in a much quicker method. This is a number actually worth knowing, that 2 to the 10 is equal to 1,024. It's actually, when you have a megabyte, sometimes it's measured as having 1,000 bytes in it, and sometimes it's measured as having 1,024 binary bytes. So slightly different measurements. If you click a file and look at the properties and how big it is, you have two different measurements. One is assuming that there's 1,000 bytes in a megabyte, and one is assuming there's 1,024. And the reason we do this is because we're working in binary, in base 2, and so it just kind of links together with it. And yeah, you only have zeros and ones and so on, and that's very close to 1,000. So it makes sense to store it in those chunks. Now, the reason that this is useful is precisely because it's close to 1,000. So 2 to the 21 is actually 2 to the 10 times 2 to the 10 times 2. So it's 1,024 times 1,024. So this only works because actually when I times these two together, I can just focus on the last two digits because there's the 0 here and the 1 are going to play no impact. So let me show you in a bit more detail, because I could write it as 1,000 plus 24 times 1,000 plus 24 times 2. So, these timesing together have no impact. 1,000 times 24 isn't going to give me the last three digits either. It's only the 24 times 24 that is going to give me the last three digits. So I can take this very quick shortcut through this. And if you knew this to start with, you wouldn't even need to do that part of it. So now I just need to work out 24 times 24. Okay, I don't know off the top of my head. So 4 times 4 is 16, 4 times 2 is 8, plus the 1 is 96, 20, put the 0 in, 2 times 4 is 8, 2 times 2 is 4, 6, 17, carry the 1, 5, 7, 6. And then when I times it by 2, well, I'm going to times it by 2, but when I times it by 2, the 5 is going to play no part because I'm just going to get 1,000. So I can ignore that actually, and I'm going to get 152. Those are the last three digits of 2 to the power of 21. And so finally, I can just add these together, and I'm going to get 354 by doing the 202 plus the 152. Okay, nice method for dealing with this. Now, let's imagine you didn't spot that. We can do it a longer way. It'll take us to the same place, but I decided to just keep times in by 2. Like obviously I'd do it this way next time if I realized it, but you're trying to do a question as quickly as you can. You don't actually always think to do, pause and think what's actually the quickest route. So when I get to 1,024, I realized that, okay, has no impact. So I'm basically starting from 24. So I'm going to get 48 96, and I just carried on this way. 192, 384. Just being careful not to make a mistake. 768. So that's 2 to the 15 now. Then 1, 5, this is a bit of a tricky one. 1536. Okay, actually, this is good because when I times by 2, this is going to go and continue into the thousands, and this is going to continue into the, I'm going to get 1072. So I only actually care about the 72. Get 144, 288, 576. Ah, that's what we got before. I've actually worked out the last three digits of 2 to the 20. So now I can ignore the 5, and I'm going to get the 152 from before. So it's not a silly method. It didn't take too long. But if it was a much higher power, 2 to the 30, 2 to the 50, then you can see why there's a massive advantage using this kind of method. So yeah, good question. I hope you enjoyed it.